A very good evening to you guys from Cheenta Statistics Analytics Department, and I am here with you to discuss today, not today, it's 12th September's problem. And this was a problem given by our student, and it's a very important problem. The ideas I will discuss over here is really important for line integrals, okay? And we'll see how we can approach this problem with the ideas of line integral, and we'll also prove the line integral idea, which is like very crux to this problem, the solution. So perfect. So let's get started with the problem. If you have not solved, please stop the video and do it yourself and come back later on to see the solution. Okay. Now coming back to the problem, you have to evaluate the integral over a circle on the quarter circle, okay, joining the same points. So what I've understood from this problem is that I didn't understand this language joining the same points, or maybe circle joining the same points along any quarter. So what I did is that I took the positive quarter. The idea is that sine and okay, I will just tell you why it's important. So I just took the positive quarter, okay, and this is the line segment, and like the one quarter of a circle, uh, like where this is cos t comma sine t. That is the radius is 1 with center at 0 comma 0. That is a circle. This is the line on which you have to integrate. Okay, this is the line with the two endpoints on which you have to integrate. Okay, and yeah, that is the basic idea. And what you need to do is understand the solution of this. How to find a function. Imagine there is a like it's a two-dimensional shape, and imagine there is a like height on this. So the height, by height I mean like the height at the corresponding points x comma y. So those heights I mean, and let's understand. So we have the height over here, and we have to find the line integral like this, and the area on the line like this. So how to do this stuff? How to do this on this specialized region? So we use something about the results of the line integral. That let's say we have a curve C, okay, and C is let's say it's going from A comma B. C is a curve, so that means it's a function from A comma B to the real number line to the R2, and this is a curve. This is the curve C over here, which is denoted by let's say AT comma BT. This is called the parametric curve, which is denoted by AT comma BT. Here it's a cos theta, cos t comma sin t. The parametric curve, it's taking a number t, and it's moving, it's like mapping to AT comma BT. AT and BT are the corresponding functions, and let's not call AT and BT GT and HT, because the and B are already used over here. So now we are planning to integrate a function integration f of x comma y dx dy on this curve C. So how do we write this in terms of uh, t, okay, and this curve? So we write this in this format, that it's coming out to be this. It comes out to be t, and t is going from A to B. F of gt comma ht times the derivative of something, and we'll see. So you have to change dx dy to dt something into something dt. So how do we find that? I will prove that why it is that way. So into it comes out to be integration, sorry, root over of g dash t whole square plus h dash t whole square dt. So here it will come out to be integration over. So it goes from 0 to pi by 2, this t. This goes from 0 to pi by 2, the t goes from 0 to pi by 2. So in this case, it will be 0 to pi by 2. Okay, by the way, f of x, y, f of x comma y is x square plus xy. So it will be cos square t plus sin t cos t. Okay, times the integration over cos t dash whole square plus sin t dash whole square. That means it's again cos sine square t plus cos square t is equal to 1. So this term is turning out to be sine square t plus cos square t whole times dt. And this is turning out to be 1. So we are getting that it's integration 0 to pi by 2 integration, cos square t plus sin t cos t dt. So I will come to this integration once again, but before that, what I will do is the following, that I will actually show you the proof of the result, like why this is true. So we have a curve over here C, and it's going from A to B. Let's say the T is going from A to B, and we have f of t over here. Okay, and f of gt comma ht. That's the idea. Okay, and we are doing integration over the C, f of x comma y dx dy. So understand that this is actually same as dx dy means this ds. Okay, so this ds, and what it means is the following, that we are actually trying to find the integration over this integral. Okay, ds, this is a ds, and it means that understand that the small are a tangent at this point, right? So if you like zoom it in, see small this small ds, this is ds, can be written in terms of dx and dy. So let's write out, understand this. So this ds is what? This ds, small ds, is nothing but this is dx and this is dy, and this length, and therefore it turns out that ds square is equal to dx whole square plus dy whole square. Okay, and this is a very important idea, and therefore we have understood that ds is equal to root over dx square plus dy square. Okay, now we have to understand something. We have to convert this into t. So what we do is that therefore ds is turning out to be, if you just write it down, and if you down ds, it's turning out to be, if you just multiply dt over here, so it's turning out to be dx. If you just take dt inside, it will turn out to be this. Just do as normal arithmetic, okay? The small infinitesimal numbers are acting as small numbers, arithmetic only. So this, see, it's like we just inserted 1 by dt whole square inside, and there is bahar dt, so it cancels out. And therefore we get ds is equal to this. And exactly that is what we get, that integration a to b, that the t is going, x we are replacing by, this is g of t comma h of t, and x we are replacing by g of t comma h of t, and ds is replaced by this root over this quantity. Okay, it's a big quantity, and that's what we have understood, and therefore we have got this result that f of xy on the curve c ds is actually equal to integration a to b f of gt comma ht into root over g dash square plus h dash square whole dt. And if you put gt is equal to cos t, because it's cos t comma sin t, you get cos t square plus sin t cos t into cos t dash square plus sin t dash square, which is equal to 1, and therefore we get this corresponding result. And therefore we have to find this integration now. It's an integration problem, therefore, and we find out that, I hope everything is clear till this point of time of how you found out the solution. It's very important, and I remember still facing this problem in my B, like when I went to give my CMI BMath exam. So I remember they gave a problem like this. Anyways, so coming back to this solution, let's understand that how do we solve this integral. It's really easy. So we do integration 0 to pi by 2. We do integration 0 to pi by 2 cos square t dt plus integration 0 to pi by 2 sin t dt, sin t cos t dt. Now observe one thing, that see sin t cos t are all if you can take any uh, like no, it will not work on any 0 to pi by 2 interval, okay? Because sin t and cos t have a period of 2 pi, so you have to fix the corresponding interval length, okay, and then start from there. So I think that is a better idea to do with it, and I think that is where we can start. It's 0 to pi by 2 because it's starting from this to this, it for something different. So if it was like this another quarter, you have to start with a different t and end with a different t. So make sure you are okay with the initial values of t wherever you're starting from, the range of t. So I have taken this blue region, so therefore my t is this 0 to pi by 2. So make sure your t ka range is fine, and therefore we have this and we have to solve this. It's very easy. So you can just do it by cos 2t whole square, and I can do it by 1 2 2 cos t square. So I am just like writing down the basic final result. I'm not doing the integration. You can do it by substituting the whole thing, and it's very easy, okay? And you can do that. So the final result will come out to be um, sin t cos t, sin t into sin t plus cos t, okay, by 2. That is the final result will come out to be. I'm leaving this as an exercise. I've done it before, so it's turning it to be sin t into sin t plus cos t whole by 2. How you're going to do this is very easy. So you can change it to cos 2t and sin 2t, and you can do some variables like substitution, and you can find this result. It's very easy. I'm not doing integration. It's a class 11 12 problem, and therefore we have got that. Therefore, if you can just like, it's not integration, it's like it's a final integrand. You have final indefinite integration, so it's 0 to pi by 2. I think it will turn out to be um, pi plus 2 by 4. I think that's what it turned out to be, pi plus 2 by 4. And it's super important, and it's a very important idea of how to find an integration over a line, and that's super important. How do you replace that ds by that corresponding length of the curve into dt? So that is super important, and that's super beautiful actually. It gives the geometry of the behavior of a curve. So I hope you enjoy the problem, and stay tuned and stay blessed. It's a lot of like, it's a very like really almost night, and yep. So see you in the next problem, and stay tuned and stay blessed. If you like our videos of solve a problem a day, do like, share, and subscribe to your friends. And yeah, that's it. Thank you for being with us. Thank you for supporting us. Yeah, bye bye. All the best. Good night.